What's up? I'm Vin, and today I'm going through the January 2023 Algebra 2 Regents, and I'm going to do the multiple choice section, and I'll leave a link to a copy of the test in the description below. So just know all the multiple choice questions here are worth 2 credits. And first up here, we have which expression is equivalent to this. So there's 2 paths that we could go here. One thing you could imagine this as is just imagine that we have u equals x plus 2, and then we could rewrite this as u squared, and then we have minus 5 times u, so we're just making a substitution here, plus 6, and then this would factor to u minus 3 times u minus 2. But then notice all of our answers are in terms of x. So then what we could do is we could plug back in for u, and then this is going to be, instead of u minus 3, we're going to call this x plus 2 minus 3 like this, and then instead of u minus 2, we'll have x plus 2 minus 2. And then notice here 2 minus 2 cancels, and in the first parenthesis we're going to have x minus 1. And then here, all we're left with is an x. So if we scan the answer choices here, you could see that it's going to be the first answer choice. And we could just use commutativity here to call this x times x minus 1. So that's the first solution. And I'll quickly go through another solution, which would be to solve this by brute force. If you were to expand this, and please don't say x squared plus 4, you got to do x plus 2 times x plus 2. And when you multiply this out, you're going to have a plus 2x in the middle. So common mistake here is people just do the first thing squared plus the second thing squared. But when we do 2x plus 2x, we're going to have a middle piece 4x, and then we have plus 4. And if we distribute the minus 5, we're going to have minus 5x minus 10, and then we just tack on the plus 6. And when we simplify this here, notice that 4x minus 5x is going to give us minus 1x. And if we have 4 plus 6, that's 10. And then 10 minus 10 is 0. So these constants all just cancel each other out. And then this simplifies to x times x minus 1, also giving us choice 1. So for the second question here, we need to solve this equation to the nearest tenth. Now we're going to need a calculator anyway to get our answer to the nearest tenth, so we might as well just use it from the start. So what I would do is we have 4,300, and then we have e to the power 0.07, and then we tack on our x, and then I'm going to get out of that by pressing the right arrow, and we have minus 123. And then the right side of the equation is 5,000, like this. Now notice you press graph, and you're like, oh no, I don't see anything. So that's because the graph is not going up high enough. And first thing I would do here is maybe stretch out the x-axis so that it could go all the way out to 68.5. So I'd go to the window, and my x maximum I'll stretch out to 70. But look, I press graph, still nothing. And that's because the right side is equal to 5,000. So that means our y maximum should go up to at least somewhere in the neighborhood of 5,000. I would go a little bit over, like 6,000. And now notice here the intersection point happens very early on. So that means it's going to be one of these first 3 answer choices. It's not going to go all the way out here. So at this point, if you want, you could adjust the graph and put the x maximum back to 10. And now this will give us a much better picture of what's going on. So I press second trace 5, and I'm going to trace the intersection point here. So I press enter before, and then I scroll a little bit after. Press enter a second time and a third time, and notice we get x equals 2.5 if we round to the nearest tenth. So our solution here is going to be choice 2. Question 3, we have the value of an automobile t years after it was purchased given by this function here, and we want to know which statement is true. So this one right away is reminding me of this formula. So we have a equals p times 1 plus or minus the rate to the t power, like this. So what it looks like here is that the initial value of the car is $38,000. And then there was a decrease here because notice 1 minus some r value would give us 0.84. So right away I'm seeing that there's a decrease, which eliminates choices 1 and 3. And then we have to be careful here though, because the amount that it decreases by, this is referring to the r value here, the rate. So right away I'm seeing here this is looking like choice 4, and the reason being that if I do 1 minus and we have 0.16, just be mindful that 16% is the same thing as 16 over 100. And that as a decimal is 0.16. So if I do 1 minus 0.16 like this, that's going to give me 0.84. And that's why our formula here has a 0.84 attached. So that's why here this car is decreasing in 16% each year, choice 4. Question 4, we want to find the function that represents exponential decay. So we're looking for something that's going to look something kind of like this. Now, once again, you do get a calculator for the whole region. So what you could do is you could type in all your answers into this section here. So now what we're going to do is we're going to graph all of these, but I'm going to press zoom 6 so that everything goes back to normal. And notice here that all of these graphs except one are going up. The red one is the one that is decreasing here. This is the exponential decay. And if we go back to the y equals here, that's going to match up with 1.8 to the negative x. So this one here is going to be choice 2. So for question 5, we could use synthetic division. And I'm going to use synthetic division because when you're dividing by a linear factor like this, x plus 2, and you just have a leading coefficient of positive 1, this is like a perfect opportunity to use synthetic division. Otherwise, you could use polynomial division. So you set the factor equal to 0, you find the root, and you write that root in front of this division bar here. And now what we have is I'm going to write all the coefficients of the polynomial on top inside. So I have 1x to the 4th. Then be careful, don't just start and go on to negative 5 here. We have to write the coefficient of x to the 3rd is technically 0. And then we have minus 5x squared plus 4x, and then our constant is at the end. So then the way this algorithm works is we bring down the first number, which is 1, and we multiply. Negative 2 times 1 is negative 2. And then we add 0 plus negative 2 is negative 2, and then multiply again. You're going to get 4. Negative 5 plus 4 is negative 1. And then negative 2 times negative 1 is positive 2. This becomes 6. And then negative 2 times 6 is going to give us negative 12 like this. And then 14 plus negative 12 is 2. And this is our remainder. So what we have when we divide by x plus 2, that's going to reduce this down to an x to the 3rd. So what we have is we have 1x to the 3rd, we have minus 2x squared, we have minus x plus 6, and then our remainder is 2, but we originally divided by x plus 2. So we're just going to scan the answer key here, and this looks like it's matching up with choice 1. So question 6, we want to find the sum of the first 20 terms of this series. And the first thing we have to be able to determine is if this is an arithmetic or a geometric series. And this is a geometric series because to get from one term to the next, we're multiplying by the same number each time. Now, you might just be able to spot that r is equal to negative 3. Otherwise, just take any two consecutive terms and divide one term, like let's say 6, by the term before it, and that would give us negative 3. This also works if I pick negative 18 and 6. If I did negative 18 over 6, that also gives us negative 3. So once we know that this is a geometric series, the sum of a geometric series, what we have is s sub n is equal to a sub 1 minus a sub 1 times r to the n divided by 1 minus r. And just one thing to point out here, n represents the number of terms that we're adding. Okay, so in this case, we're going to have n is equal to 20. R is our common ratio. So we have to know what each term means in this equation. And then once again, n is the number of terms. And just be mindful here that a sub 1 is the first term. So let's start defining stuff here. We have a sub 1 is equal to negative 2. We're going to have n is equal to 20 because we're adding the first 20 terms. And then what we also have here is an r value of negative 3. So then all we have to do is plug into this formula. We're going to have the sum of the first 20 terms is equal to a1, and we're going to have negative 2 minus a1 is still negative 2. We're multiplying by r, which is negative 3, to the n power, which is 20, and we're dividing by 1 minus r. We have negative 3. Now, there's a lot of negatives here, so just make sure you put a lot of parentheses in. So we'll go back to the main screen here. And when you're typing in a fraction, my advice is to press alpha y equals enter, and it pulls up a blank fraction. So I'm going to write this with parentheses. We have negative 2, and then I'm going to write minus. So I'm going to actually use the subtraction sign here for this, not this negative sign. And then we're subtracting negative 2 times, we have negative 3 in parentheses, and this is being raised to the 20th power. So just make sure you play it safe and put plenty of parentheses, because if you don't put parentheses, the calculator can steer you in the wrong direction. And we have 1 minus negative 3. And then now we just press enter, and here's our solution. So our answer here is going to match up with choice 3. Question 7, we have if f of x is this polynomial, then f of 1/2, and we have 4 options to choose from. So the first thing I would determine is if f of 1/2 is equal to 0 or if it's not equal to 0. So we could go back to the y equals here, and I'm just going to clear everything out. And what we're going to do is we're going to type in the function. Now the problem here though is if we go to the table pressing second graph, notice there is no option for 1/2. So if you want to manually input values, you press second window and you switch the independent variable from auto to ask. And what that does is when we go back to the table, if I type in 1/2 like this, or I could write it as 0.5, notice that our y value is 0. So that tells us right away that the function at 1/2 is equal to 0. And if I press graph here, notice I could rely on my eyesight, but I'd rather go to the table here because this will make me feel safer. So the table gave us y equals 0 when x was 1/2. So the function is equal to 0 at 1/2. So we could eliminate choices 3 and 4. But now we need to determine which of these is a factor. So if we set 2x plus 1 equal to 0 and we set the other factor equal to 0, this will tell us the root that comes from each of these factors. And if we subtract 1 on both sides, we have 2x equals -1, giving us x equals, and just divide both sides by 2, we'll have x equals -1/2 is the root from this factor. But then when we solve this one, plus 1 on both sides, we have 2x equals 1. And now check it out, we get x equals 1/2 as the root. So which of these matches what we started with? Well, we had f of 1/2 is equal to 0. So we could chop this one out, and it's looking like 2x minus 1 is our factor. But if you really want to play it safe here, what you could do is you could plug in -1/2 and see that it gives you something non-zero. So we're back at the calculator screen here, and we're back at the table. So I want to just type in -1/2. And if I get something non-zero here, I'll feel very good about our answer. And check it out. At -1/2, we get y equals 16.25. So x equals -1/2 is definitely not a root. So 1 is out, 2 is definitely our answer. Question 8, we have some tricky algebra to do to solve for the value of k. And I would start this by expanding the left side. So we have 6 minus ki squared, which we could expand like this. 6 minus ki times itself. And that's equal to 27 minus 36i. And what we're going to do is distribute on the left. So we have 6 times 6 is 36. And then we have 6 times minus ki is minus 6ki, and then we have 6 times another minus ki is another minus 6ki, and then minus minus goes to plus, k times k is k squared, and then I times I is I squared. And now just know for imaginary numbers here, I squared is equal to -1, so we're going to need that in a moment. And the right side is going to stay intact like this. So the trick here with imaginary numbers or complex numbers, you want to get the real terms together and the imaginary terms together. So notice here that we have 36, and in a moment this is going to turn to a real number, because when we do I squared is -1, we're going to have k squared times -1 is going to give us minus k squared. So we're going to have this part here is going to be real. We're going to have 36 minus k squared. So this is our real part. And now what we have next, we have minus 12ki, and this is our imaginary part. And this is going to be equal to, and I'm going to write our real part now in pink. On this side, the real part is 27. So we have 27, and now we can just tack on the imaginary part, minus 36i like this. So now any one of these you could set equal to each other. If you set the blue stuff equal to each other, you would have minus 12ki is equal to minus 36i. And notice here, if you divide by -12i on both sides, that the i's cancel, and -12 over -12 cancels, giving us k equals, and this is going to simplify to +3. So 3 is looking good. And if we plug in k equals 3, watch what happens. We have 36 minus 3 squared, and this is going to give us 36 minus 9, which is 27. And see how the 27 matches what we have over here as well. So that's a really good sign. So question 9, we're solving a rational equation. And the first thing I like to do with these is say which x values are not possible. And these are the x values that make the denominator equal to 0 for one or more of the fractions. So right away I see x equals 0 would be a problem, because it would make the first and third fraction have a 0 denominator, and that would make this equation undefined here. So that tells us x is not allowed to equal 0, which is going to eliminate choices 2 and 4 because they have 0 included in their solution set. So now what we could do is to solve this, all we would really have to do is plug in x equals -3 and x equals +3 and see which one gives you a true equation. And that would work out to x equals 3. Otherwise, what we could do is if we want to solve this by hand, we could find the least common denominator. And in this case here, we have a denominator of x, 3, and 3x. So the least common denominator would be 3x. And that just basically means that's the denominator we want all of these to have so that we could actually move forward with solving this. So the first part here, I would multiply by 3 over 3, and that would make a denominator of 3x. And then the second fraction, I would multiply by x over x, so it has a denominator of 3x. And now if we go forward here, we would have 3x plus 6 over 3x, and then we would have plus x squared over 3x is equal to, and the last fraction we leave alone is 2x squared plus 6 over 3x. But you could see right away that this is like definitely a lot more tedious than just plugging in these numbers, but it will give us the right answer. So notice here, once you have all matching denominators, just think of it as multiplying everything by 3x, and the denominators all cancel. So then what we have here is we have 3x plus 6 plus x squared equals, and we have 2x squared plus 6 like this. So then from here, what I would do is move everything to one side. So we could do minus x squared on both sides. Then we could do minus 6 on both sides. And we could do minus 3x on both sides, all in one step. So I'm going to do this, and you'll see here, this cancels, this cancels, this cancels, and I'll draw the arrow, and we'll switch colors here. Now on the left, we have 0 equals 2x squared minus x squared is just x squared, plus 6 minus 6 cancels, and we have minus 3x, which if we factor is going to give us x times x minus 3. And this is going to give us two roots. We're going to have x equals 0, and then the second factor, x minus 3 is equal to 0 when x is equal to 3. So notice we get 0 and 3. So 4 was a very dangerous trap. Why this is a problem is that it's just x equals 3 because you have to, with rational equations, you have to plug your answer back into the original here. And if we were to plug in x equals 0, that's going to make this undefined. So choice 3 is definitely our answer. So question 10, we want to see how many real solutions exist for this system below. So for this one, we could just type in both equations to the calculator. So I'll write 1/4 as 0.25x, and then we have minus 8 we're just tacking on. And then underneath this, we have 0.5 for 1/2, and then we have x squared, and then we're tacking on a 2x. So now I'm going to press zoom 6 just to make sure our graph is back to standard here. And notice that these graphs completely miss each other. This quadratic is not going to intersect with this line. So there are no real solutions between them. So this is going to be choice 4, but let's say this is bothering you and you're like, wait, how do I know they're never going to cross? Well, one thing you could do here is you could set them equal to each other like this. So I just set both equations here equal like so. And then what we could do is I would multiply everything by 4 just to get rid of the fraction. So that would give us x minus, and then 4 times 8 is going to give us 32, equals 4 times 1/2 is 2, so I have 2x squared, and then 4 times 2x is 8x. And then here I would move everything to one side, so I have minus x on both sides, and then I would do plus 32 on both sides. And if I want to be 100% certain here that we have no real solutions, we could look at this quadratic equation here, 2x squared plus 7x plus 32. And remember the quadratic formula, the part that determines what type of roots you have is the determinant, which is the piece under the radical. So all I have to do here is find the determinant of this quadratic. And if we define each piece, we have a equals 2, we have a b value of 7, and we have a c value of 32. And if we look at the b squared minus 4ac, see how we would have 7 squared minus 4 times 2 times 32 like this. And just looking at this, I can see this is going to be 49 minus 8 times 32. And I could multiply this out, but I'm pretty safe here to say that 8 times 32 is definitely bigger than 49. So I'm doing 49 minus a number bigger than 49, which is going to be less than 0. And anytime you have a negative under your radical, that means you're going to have imaginary roots. So our roots here are going to be imaginary. So if both of our roots are imaginary, that means we have 0 real roots. Question 11, which equation represents a polynomial identity? And for this one, choice 1 is definitely out. Please don't fall into this trap here that when you expand this, you need to be doing x plus y times itself 3 times, and you have to do the distributive property a whole bunch of times. It's not as simple as doing the first thing to the third plus the second thing to the third. So this choice is definitely out. Now for the remaining answer choices, there's kind of a way we could cheat a little bit here. Is let's say we look at what's the first term times the first term. Notice that this is going to start with x to the third, and when we do the last term, y times y squared, so we have a whole bunch of stuff, we're going to end with y to the third. But then when we look at the other answer choices, watch what happens. We have x times x squared is going to give us x to the third, but then we have y times minus y squared. So we have a whole bunch of stuff, and y times minus y squared is minus y to the third. So there's no way we're going to get a plus y to the third out of this, so this choice is out. And then if we look at the last answer choice here, notice what we have. We've got x times x squared, so this is going to start with x to the third. We get a whole bunch of stuff, and then we have minus y times y squared is minus y to the third. So there's no way we're getting x to the third plus y to the third out of this. But let's say that's bothering you. If you really want to play it safe, what you could do is you could actually take the time here and distribute this all the way through. So we have x times x squared is x to the third. We have x times minus xy is minus x squared y. and then we have x times y squared is plus x y squared, and then we have y times x squared is plus, I'll write it as x squared y, I'll put the x's first, y times minus xy is minus xy squared, and then y times y squared is plus y to the third, and check out what happens. Minus x squared y with plus x squared y, they cancel out. Xy squared cancels minus xy squared, and then we're just left with x to the third plus y to the third. So choice 2 is definitely our polynomial identity. So question 12, we have to know our law of exponents, and we're given that x is greater than 0, so we don't have to run into any issues involving absolute value. So here, this is the law of exponents we want to know, that when we divide exponents with the same base, we subtract their exponents. So this we could say is equal to x to the, now we're subtracting fractions here. Now, if you really have to, you could go to the calculator and do this and press math, enter. There's no shame in not knowing how to subtract fractions. Otherwise, you need to find common denominators. We have times 2 over 2, which would give us 2 over 10, minus 1/2. If we do times 5 over 5, could be written as 5/10. And then 2 over 10 minus 5 over 10 is negative 3 over 10. So this is equal to x to the negative 3/10 like this after we subtract those powers. And now this, we have x to a negative power. We could write this as 1 over x to the positive 3/10. And just know when you want to write this in radical form, the number on top is your power and the bottom number is your root. It's power over root. So this I could say is 1 over x, and then the root is 10. So I have a 10 in front of my radical in the index spot, and the power on the inside is 3. So now just scan the answer choices. This matches choice 3. So question 13, we have a cyclist pedaling at this rate, and the height h of a pedal at time t in seconds is plotted below, and the graph is modeled by this function, and we need to find what is the value of k. So for this, it helps to know that the period of a sine or cosine graph is equal to 2 pi divided by k, where k is the frequency and it's the coefficient of the variable on the inside. So this represents the frequency. And what I could do here is if I want to find what is the period of the graph, that represents the amount of time it takes to complete one cycle. So if I trace this graph here, notice I'm going up, I go down, and then I complete a full cycle here. It takes me a distance of 1 to complete a full cycle. So that tells me that I have 1 equals 2 pi divided by k. And if I want to solve for k, just cross multiply. I have k times 1 equals 2 pi times 1. K is equal to 2 pi. So this is going to match choice 2. So to check our answer here, we could type the function into the y equals. So we had 5 sine, and our answer for k was 2 pi. So I'm going to write 2 pi, and then I know it's in terms of t, but x is our variable for the calculator, so that's not going to affect anything. And if I press graph, notice this doesn't help us at all, but the graph that we had given to us went from a t value starting at 0 and stopping at 5. So I would change the x minimum to 0 and the x maximum to 5. And now when I press graph, this gives us a better picture. So once again, we set our x minimum to 0 and our x maximum out here to 5. And you can see here that this breaks it up. So we have 1, and then we do another full cycle here at 2, and then to 3, and then to 4. So this graph here definitely checks out with k equals 2 pi. Question 14, which statement about data collection is most accurate? So this is kind of the common sense question, and I just picked the answer choice that sounds the best. So here we have a survey about parenting styles given to every 10th student entering the library will provide unbiased results. All right, this one is not sounding good because if kids are going to the library, their parents are more likely to be strict. So right away, there's the bias. And then next we have an observational study allows a researcher to determine the cause of an outcome. Well, this one is already not sounding good because just imagine you're observing the public and you see someone riding a bike. You can't just say, all right, the cause of this is because this guy's dad is probably like a professional biker. Like, yeah, maybe in some rare case that is the case, but you can't make leaps like that just based on an observation. So this one is not sounding good. So choice 3, we have the margin of error increases as a sample size increases. And for this one, I just imagine a math test. And let's say this is like a 5th grade math test and the average is a 70. And this is for, let's say, New York State. But then they go to another state where students are scoring just about the same. So if you increase the sample size and you have, let's say, Texas, they take the same test. Maybe they get an average of 70 as well. So we're increasing the sample size, but the margin of error is not increasing. Because once again, margin of error is the amount that a value might go above or below. So they're staying within a reasonable amount here of the norm. So increasing the sample size is not going to affect the margin of error. So now just by default, it has to be 4, but let's read this and hope it's something nice. And we have a survey collected from a random sample of students in a school can be used to represent the opinions of the school population. This one is sounding good because it is a random sample of students. So for this one here, that will give you a general idea of the opinions of the school population. So question 15, we have f of x and we want to find the inverse function. And for this, what I like to do is I switch the x and y. Normally this will say something like y equals, and then we have our function of x. So when I say switch x and y, just know f of x is equal to y. And what we're going to have is we're going to have x equals 1/2 y, and then we have plus 2. So then what we do from here, after we switch x and y, we solve for y. So we're going to do minus 2 on both sides. And now we're going to have x minus 2 is equal to 1/2 y. And now to solve for y, to get rid of this 1/2, we're going to multiply both sides by 2. So I could just show this by putting a jumbo parenthesis like this. And now 2 times 1/2 y is just going to give us y, because 2 times a half just cancels out. And we have y equals, and we have 2 times x is 2x, and then 2 times minus 2 is minus 4. So our solution here, f inverse, is going to be 2x minus 4. Question 16, we have f of x, and we want to know for what values of x will f of x be greater than 0. So we could do this one by hand, but if you have a calculator, why not use it? So we have x to the 4th. So we're typing this in the y equals, and we got minus x to the 3rd. And now make sure you hit the right arrow to get out of the exponent spot. You got minus 6x squared. And now I'm going to press zoom 6 just to make sure our graph goes back to normal, and we're going to borrow this for the question. Now just know if we had to continue this, we could. This is going to make a loop like this before it goes back up. But if we're looking for where f of x is greater than 0, in words, this means when the graph is above the x-axis. So it's very important to know what it means for f of x to be greater than 0. It's when the graph is above the x-axis. And this is because f of x, we usually have y equals f of x. So we're looking for when is the y value greater than 0, and the y value is the vertical component. So now we just look, and we could see here that if I highlight, notice this portion of the graph here, the graph is above the x-axis. Then it goes under, it wants to go back over, but it stays under, and then it comes back over again over here. So now we just have to count. We could see here that at x equals -2 is when the graph goes under the x-axis, and then it's under, and then at x equals 3, it goes back above. But notice here that it's highlighted for x values less than -2, and also for x values greater than 3. When the graph is to the left of -2, it's above the x-axis, and when the graph is above the axis again, that's when x is greater than 3. So we look for the answer choices. That's going to have both of these, x less than -2 or when x is greater than 3. Question 17, we're solving this equation, and we're going to have to use the calculator again. So let's go back to the y equals, and we've got on the left side, we have log of x plus 5. And now this is equal to, so we're going to write the next part of the equation on the y2 spot. Absolute value is math, go to the right and go to ABS. And then we've got x minus 1. Hit the right arrow to get out of there, and we write our -3. So now zoom 6, we'll put the graph back to normal. And notice we have two solutions here. So I'm just going to press second trace number 5, and that's going to trace the intersection here. So I go before the intersection, I hit enter, I scroll after, I hit enter again, and notice here that we have -2.41 is one of the values of x that makes this work. And if I want to get the next one, I have second trace 5 again, and next up here, so we're going to go over to this second intersection point, we hit enter a second time, and a third time we have x equals 5. So the calculator told us x equals -2.41 and x equals 5, and this will match up here with choice 3. Question 18, we have a cubic polynomial with these characteristics. It has one real root, and as x goes to infinity, f of x goes to -infinity. And just know f of x we could also call y. Y is going to -infinity. A and B are positive, and which equation represents a cubic polynomial with these characteristics? So right away, choice 3 is out because -x squared times x squared would give you a leading term of -x to the 4th, which would not be a cubic polynomial. Cubic means it has to have a leading term of x to the 3rd, and it could be plus or minus some number in front. So then next, what I want to envision here is that as x goes to infinity, so that means as we go all the way to the right, the y value is going to -infinity. So that means the end behavior is going to look like this. And if you really know your polynomials, that means that our leading term is going to be a minus x to the third because it's going down to minus infinity like this. So then that would allow us to eliminate any answer choice that has a positive x to the third, like choice 1. Notice that x times x squared here, this is going to have a leading term of x to the third power. So now it's between the last two answer choices. And depending on your knowledge of polynomials, this might be easier for you to just pick out random values for a and b. Like let's say we pick out a is equal to 1 and b is equal to 4. Well, if we work this out, let's say for choice 2, we would have f of x equals 1 minus x, and then we have x squared plus b, or x squared plus 4. And then for this choice here, see how we would have f of x equals x minus 1, and then next we have 4 minus x squared. So which of these choices could we eliminate? We're going to be able to eliminate choice 4. And the reason being that if we were to find the roots here, we would have x minus 1, and then this piece here would factor down to 2 plus x times 2 minus x. And we would set this equal to 0. So the fourth answer choice would actually have 3 roots. It would have one at x equals 1, x equals negative 2, and x equals positive 2. Whereas this one, notice that x squared plus 4 on its own is a quadratic that looks like this, and it has imaginary solutions here. You could see that you'd have x squared plus 4 equals to 0, would give you x squared equals negative 4, and notice you'd have x equals, we would have plus or minus 2i. So notice if we took the square root of both sides here, the square root of negative 1 is I, and then the square root of 4 is 2. So we would have plus or minus 2i like this, which would be imaginary roots, but this one would be our one real root. If we solve this equation, we would have a root of x equals 1. So notice the fourth answer choice gave us 3 roots. The second answer choice just gives us 1 root. So this is definitely our solution. If you really want to play it safe, what you could do is you could type in the answer choice we just selected for our values of a and b, and we're going to graph 1 minus x, and then what we have next is x squared plus 4. So we just write x squared plus 4. We don't actually have to distribute this. We can leave it in factored form. And now I'm going to press zoom 6 just to make sure the graph is back to normal. And notice here's our 1 root at x equals 1. And as x goes to infinity, the function or y value is going to minus infinity. So question 19, take a second to read through this. The actual question is, considering the middle 95% of the data, what is the margin of error? And remember, the margin of error is the amount that a value might be above or below. So what are we allowed to go above or below? We're allowed to go above or below 2 standard deviations. So what we need to find here is, what is 2 standard deviations? 1 standard deviation is this. So 2 standard deviations would be 2 times 0.35. And this we could just type in a calculator, or if you multiply this out, this is going to be 0.07 like this, and that's going to match up with choice 4. Question 20, we have cosine A is radical 5 over 3, tangent A is less than 0. What is the value of sine A? So for these questions, I like to use this. We have ASTC, and this stands for all students take crack. No, what it actually means is that all the trig functions are positive in quadrant 1, sine and its reciprocal are positive in quadrant 2, tangent and its reciprocal in quadrant 3, and then cosine and its reciprocal are positive in quadrant 4. So if we have cosine of angle A is positive radical 5 over 3, that means we could be in quadrants 1 or 4. But then next up we have tangent A is less than 0. So tangent of angle A can't be less than 0 in quadrant 1. So that means we have to be in quadrant 4. So then what I do from here is I set up a triangle, a right triangle, and I'm going to label this angle over here as angle A. And if cosine of A is square root 5 over 3, that means I could label the side adjacent to A. I'm going to label that square root 5, and the hypotenuse I'm going to call 3. So this is the hypotenuse. So then to find the opposite side, what we're going to do is we could use Pythagorean theorem. So let's say I just call this, I don't know, let's say y for now. I would have radical 5 squared plus y squared is equal to 3 squared. And that would give me 5 plus y squared is equal to 9. And then if I subtract 5, I got y squared equals 4. And since we're on a triangle here, I'm just going to say y equals 2. I'm not going to worry about the plus or minus. And now from here, since y is equal to 2, now what we have next is we're able to evaluate what is sine of angle A. Well, sine of angle A, remember what we said before is that A is in quadrant 4. So since A is in quadrant 4, just cosine is positive. So I'm going to say right away that sine of A is negative. And then I use the triangle to help us here. Sine is the ratio of the side opposite, which is 2, over the hypotenuse is 3. So sine of A is going to be negative 2/3. Question 21, we have a tree farm that has 150 trees initially, and then each year 20% of them are cut down, 80 seedlings are planted. Which recursive formula models the number of trees a sub n after n years? So if it's recursive, that means there needs to be an a sub n minus 1 component in the a sub n formula, because a sub n minus 1 means the term before. That's what it means to be recursive. So choice 3 and 4 are out, because notice there is no a sub n minus 1. So now the $1,000,000 question is it choice 1 or choice 2? And for this, what I want to think about is if 20% of the trees are cut down, that means 80% remain, and 80% is equal to, so I'm going to say 80% is the same thing as 0.80. So this one is a dangerous answer choice, choice 1. It's going to be choice 2, because what this means is we have 80% of the trees from the previous year and then plus the 80 seedlings that are planted. So that's why it's choice 2. So question 22, we have which equation represents a parabola with this focus and this directrix? And for these kind of questions, I really just have to draw them out. I can't memorize formulas. So the focus is at 4, -3. So that's over 4 and then down 3. So I'm just going to label this a little bit. So here is our focus, and the directrix is at y equals 1. So I'm just going to draw a horizontal line like this, and this represents our directrix. So this is the line for the directrix. So now when I want to actually start graphing the parabola is the set of points that are the same distance away from this focus and this directrix. So right away I can see 1, -3, like these two. If I take the average of them by adding them and dividing by 2, that's going to give me an average of -1. So I'm going to start off here at -1 on the y-axis, and I'm going to go right above the focus, and that represents the vertex of our parabola at 4, -1. And now the actual parabola is going to open like this, because once again, every point on this parabola, and let's make that a little bit neater, but every point on this parabola is going to be the same distance away from f as it is from the line. So that means if I take any point on this, like let's say xy, the distance from here to here is going to be the same as the distance from here to here. So then what I like to do for this is the line y equals 1. The distance between this point and this line is simply the vertical distance. And anytime you want to find vertical distance, like let's say I'm asking how far away are these two numbers, you know it's just 2, but you could do the top number minus the bottom number and you get 2. So here I could just say 1 minus y, but just to make things simpler, I'm going to take the distance of both and square them. So here what we have is I'm going to take 1 minus y and square it, but just know 1 minus y squared is the same thing as y minus 1 squared, because when you square a positive or negative, it doesn't matter. Like if you have a positive or negative, it's going to ultimately work out to the same thing because you're squaring it. So I'm just going to call that y minus 1 squared. And what we're going to get out of this is that this is equal to this distance squared, but the focus, remember, is at 4, -3. And just remember the distance formula is going to be the difference of the x values squared plus the difference of the y values squared like this. So if I take the distance squared, you see how the radical just disappears. So here what I'm going to have is I'm going to have x minus 4 squared. So I'm going to do x minus 4 squared plus y minus -3 squared. And y minus -3 will change to y plus 3 squared. Now I could get lazy here and see that the only answer choice that has an x minus 4 squared is the fourth choice, but let's go ahead and see what happens when I expand the rest. So I'm going to leave this part intact, but if I expand y minus 1 squared, I'm going to have y times y is y squared, but then I'll have, if I actually have to multiply this out, I would have y times minus 1 is minus y, but then I would have another minus y, which will give me minus 2y and then plus 1. And this is equal to, I'm leaving this alone, x minus 4 squared, and then this would expand to y squared plus 6y and then plus 9. So right away, looking at this equation, see how the y squares are just going to cancel out. And then if I write this over here, we have -2y plus 1 is equal to x minus 4 squared. And what we have left is plus 6y plus 9. So this, there's a few ways I could go forward with this, but looking at what the answer choice is going to match out to, I'm going to go ahead and move this stuff to the other side. So minus 6y, and then I'm going to do minus 9 on both sides. And I'm running out of space here, so I'm going to write this over here. So now we work this out. We have minus 8y minus 8 is equal to x minus 4 squared. And then here we could factor out a minus 8, and we're left with y plus 1 on the inside. So once we get to this step here, we're going to see that this does match choice 4, so that's definitely our answer. So take a second to read through question 23. So Mia has student loans. They're in deferment, which means she does not need to make payments, but they are still charging her interest. And this is how much money she owes based on this function. X is the number of years since the deferment began. And if the bank decides to calculate her balance showing a monthly growth rate, an approximate equivalent function would be. So when I hear this, I automatically think of this formula. We have A equals P times 1 plus or minus the rate divided by N to the NT. And remember, N represents like the number of times per year that the loan or the amount is compounded. So if it's going at a monthly rate, I'm right away thinking of N is equal to 12. So it's like we have to the 12t, or in this case, the 12x. So right away, I'm going to eliminate these choices because we wanted to say something like to the 12x power. But now the next piece that you need to know here is this law of exponents. And it's a sneaky application of this law, because what you're going to do is you're going to take f of x, and we have this here. And what we want to do is we want to take this 1.0325, and I'm going to leave a space. We want this to go to the 12x power, but you see how originally right now it's just to the x power. So then how can we write this in terms of something to the 12x? Well, if I put a 1 over 12 here, notice how putting a 1 over 12 here, when I multiply 1 over 12 by 12x using this law of exponents, that's going to bring us right back to where we started. So then all we have to do to answer this is we're just going to type this expression here in the calculator to see what is going to be the base. But if I had to make a prediction here, notice how this base matches the original base. So you can't just change your exponent and hope no one notices. So that's why this one's out. It's definitely choice 1. But let's just verify that this number here to the 1 over 12 is equal to 1.0027. So we've got 1.0325, and we're raising this to the 1/12th power. And let's see what decimal we get. We get 1.00266, which will round to 0027. So that definitely matches choice 1. So question 24, our final question. Which graph shows a quadratic function with 2 imaginary zeros? So for this one, I'm looking for something that has no real roots. And if it has no real roots, that means it's not going to hit the x-axis. So right away, I could see that it's choice 2. But let's look at why the other answer choices are no good. See how this one here has 1 real root. So this one is out. This could be something like, let's say y equals x minus 2 squared. And then this would be the point 20. So it has just 1 root here. And then this one is not quadratic. Quadratic means that it's going to look something like this. It's either going to be frowning at us or it's going to be smiling at us. So this one's out. And this one here, notice this is not a quadratic function of x. It's a parabola if we look sideways here, but it's not a function of x. And notice we do have, if we treat it as an equation, we have a root here that is crossing the x-axis at this location. So this one is out. And then for this choice, the actual answer, let's say I actually write a function for it. If I were to call this something like, it looks like negative x squared, let's say minus 4. And this I could factor to negative, and we have x squared plus 4. And if I set this part here equal to 0, x squared plus 4 is equal to 0 is true when I have x squared equals negative 4. And if I take the square root of both sides, I get x equals plus or minus. The square root of negative 4 is going to be I times 2, or I could say 2i like this. So here is our function with 2 imaginary roots, and it's a quadratic function.